Hi student, this is a video about the thermal expansion's equations. For the thermal expansion, we have this equation that you can see in almost of the textbooks. As shown, that is delta L equal alpha L naught delta T. Okay, before we continue further, I want you to make sure that you have these two things. The first one, please make sure you have your pen, pencil, white paper and calculator. And the second thing is, please make sure you have your flux in order to participate with the flux questions. Okay, I give you 30 seconds and please ready.
T minus 30 seconds. T minus 20 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
We want to break down the equation to see what each of these symbol means. The first two things that we're going to look at are the ones with L's, delta L and L naught. Delta here means is the change of length. Delta means changing. You can calculate that by using final length minus with the initial length. The L naught is the original length or the initial length, and some textbook might denote Li as the original length. So, for both L, the standard metric units is meters. However, any length of units are acceptable as long as you use it consistently in the whole calculation. Next variable, we want to look at the delta T. So again, the delta is the change of the temperature. Delta here means changing. So delta T is the change in temperature where the final temperature will minus with the initial temperature. The standard metric unit of Kelvin is what we use in this temperature. But it turns out that the change in temperature in Kelvin is exactly the same value as the change temperature in Celsius. So Celsius value in temperature can be used as well. The last variable is the alpha, linear expansion coefficient. Okay, extra notes for you. There are two types of thermal expansion. The first one is volume expansion, in which way the solid object expand or contract upward in all possible direction. And there's also thermal linear expansion that we focus in the lectures today, where the solid object expand or contract along the horizontal axis or along the vertical axis. Okay, back to the variable of the alpha. That alpha depends on what type of material you have, and it describes how that particular material reacts with the changes in the temperature. So most of the time you need to figure out what type of material you got. You look at the table of linear expansion coefficient, where you can get it from the textbook notes or you can search online. Example 1. A steel rod with 200 meter long is at 25 degrees Celsius. That's the initial temperature. You need to calculate the change in length of the rod at negative 40 degrees Celsius and B 40 degrees Celsius. So essentially we have to use this equation, and we need to determine what alpha is for the steel, and we can find the alpha from the table of coefficient linear expansion, where the value is 12 times 10 negative 6. The coefficient value of 12 times 10 negative 6, you multiply with the 200 meter, it is the initial length, and multiply with the change of the temperature. So here, the change in the temperature is the final temperature, negative 40, minus with the initial temperature of 25 degrees Celsius. Okay student, take the calculator and calculate, see what's the answer. We'll check later. I give you 10 seconds. The answer is negative 0.156 meter. Did you manage to get the same as mine? Okay, This negative sign simply implies that the steel rod contract and it's not expand. It contract because the temperature decreases, so the molecule vibrate less violently and therefore the distance decreases. Okay, let's move on to part B at 40 degrees Celsius. I want you to solve on your own. I'll get back to you and check the answer after 10 seconds. Okay, student, how's it goes? Thank you for trying to find the solution. A big applause to you. The answer is 0.036 meter. Do you manage to get same as mine? Okay, the positive result shows that the rod expand. Hi students, you already completed with the thermal expansion calculation, and please remember you always can rewatch the video and do extra exercise. And one more thing, don't forget to answer your flux question. If you have any questions about week 6 lecture or any other issues, please post them on the Google form, ask me anything. Or you can use another platform where it's named as a Flipgrid ENG1002. Flipgrid is a very simple. You can post a questions and upload through a very short video. And let's engaging and have fun. Bye.